Hello students and friends. In this short video, you will know the answer and explanation to question number 1 in the series of physics questions in Watch and Learn. This is the question that I posted yesterday. It reads, which of the following quantities is or are necessarily changed when a body changes its linear velocity? Choices are letter A, acceleration, letter B, momentum, letter C, kinetic energy, or letter D, net force on it. So what's the answer to this question? Alright, correct answers are option letter B and letter C. We say that when the velocity of a body changes, its momentum and kinetic energy also change. We define momentum as the product of mass and velocity. And when there is change in velocity, automatically there is change in momentum. That is, delta P is equal to m delta V. Likewise, when the speed or magnitude of the velocity changes, we say that the body also changes its kinetic energy, Ke being equal to 1/2 the mass times the square of the speed or magnitude of its velocity. So when there is a change in the magnitude of the velocity or the speed, it follows that there is also a change in its kinetic energy. Why are options A, acceleration, and D, the net force acting on the body, not necessarily correct answers? We say that when the velocity of a body changes, it is said to be undergoing acceleration. Okay? But this acceleration may or may not be changing. Normally, when the velocity of a body changes, either it changes in the magnitude, change in the direction, or change in both magnitude and direction, okay, we say that the body is undergoing acceleration. But it doesn't necessarily follow that the acceleration is changing. It depends on how the F net or the net force acting on the body is, whether the F net is a constant net force or if the net force is also changing. All right? According to Newton's second law of motion, when there is a net force acting on a body, then the body will also accelerate in the same direction as the net force. Net force can also be written as the product of the mass and the change in the velocity from v naught to the final v divided by t. Alright, so we say that a body that accelerates, there is a net force acting on it. But just because the body's linear velocity is changing, it doesn't always follow that its acceleration is changing or that the net force acting on it is changing. Okay? Because between change in velocity and acceleration, it is acceleration that is considered the cause, and the effect is just the change in the velocity. Likewise, between acceleration and the net force, it is the net force that causes a body to accelerate. All right, so to summarize, when the linear velocity of a body changes, all right, its acceleration is not necessarily changed, or that the net force acting on it is not necessarily changed, but both the momentum and the kinetic energy of the body are also changing. Thank you very much for watching. Please follow me in my FB page, and please don't forget to subscribe to my YouTube channel.